For our next question, they ask you to calculate the current in resistor C. That's the one way over here. It's easiest to start off with the most basic circuit that you can. So if we consider that we just calculated the entire resistance, keeping in mind in these free response problems, they sort of walk you through a logical progression in solving the problems. So calculating the equivalent resistance is one of the first things that you'd want to do. We'll say we have a 12-volt source hooked up to a 533 ohm resistor. So 533. If we have resistance and voltage, then we have current, given by Ohm's law, V equals IR. Here we have V and R. So V divided by R will yield current. So we can find that, and it is 0.0225 amps. Now some people ask, why is this useful? Well, we know that our circuit's not just one resistor in series with the battery, but we can step back a little and say it's in fact a 12-volt source with a 400 ohm resistor in series with something that's equivalent to 2 in parallel, a 133 ohm resistor. And this is significant because now we can borrow this number 0.0225 amps. That's flowing through this resistor, and given that these are both in series, we can say 0.0225 amps flows through here, and 0.0225 amps flows through there. So since RC is eventually going to be in this branch right here of 133 ohms, let's write that right here, 0.0225 amps. And now if we have resistance and current, I and R, we might as well multiply them together using Ohm's law to find out what the voltage drop is. Multiplying those two together, we find that the voltage drop is 3 volts. Lastly, why is this significant? Well, we know that we don't have a 133 ohm resistor, but this in fact represents a 400 ohm resistor in parallel with a 200 ohm resistor. They have a different current, obviously that divides it between them, because in parallel the currents are different, but the voltage is the same. So that means across RC we have 3 volts. And finally, we know that this is a 200 ohm resistor, so we can calculate current with V and R. So simply do 3 divided by 200, and you'll get your answer, which is current, which is 0.015 amps. Just kind of for fun, we know that the same voltage is across here, 3 volts across 400 ohms. If you want to find out the current there, you get half the current from this, because it's double the resistance, and you'll end up with 0.0075 amps. And when you add those two together, you get back to, guess what, 0.0225 amps. Because what flows in through here gets split up between the two and then recombines back down here. Cool thing. So for part C, they gave you a point for correctly finding the parallel resistance, 133 ohms. They gave you a point for adding 400 and 133. And they gave you a point for the correct numerical value, 533. So 3 points there. We only have 2 more points left, actually, for part we have 3 points left for part D and 2 points for part E. Well, I got all mixed up. That was just part D. What we did, now we're on to part E, and like I was saying, that is worth 2 points. So what we have here is a slightly different circuit. We're going to take out this resistor, so we can sort of just ignore this, and we're going to take this resistor out and instead replace it with a capacitor, which looks like just 2 parallel lines without that squiggly thing in between them. Obviously, it's a big gap. This is what a capacitor symbol looks like. That's a capacitor, and this is a resistor. This is how you draw them in a schematic. A capacitor holds a bunch of charge. It's a little canister of energy, if you will. And there's a big air gap in between, let's say, two metal plates. Or maybe instead of air, they fill it with something like plastic or paraffin wax. Things that don't conduct electricity is the thing to keep in mind. So whenever you look at a capacitor in a circuit, you can think right away there is no current flowing through this device. Current will flow through a resistor and through a switch, of course, but not through a capacitor. So we have now current flowing through a different path. It comes out of the battery, goes through 2R, goes through RC, and then goes through here. So now if we know that RA is 400 ohms and RC is 200 ohms, we know that the equivalent resistance is 600 ohms. Given that this EMF over here is 12 volts, we can find the voltage drop across the resistors. And so for RA, given that it's 400 ohms and we have 12 volts, we've added 200 to 400 to find 600, and now we can find the current through all of them. Taking that current and multiplying by the resistance, we find that the voltage drop across A is 8 volts, and the voltage drop across B equals 4 volts. Notice that 8 plus 4 makes 12. So when we go around the entire loop, we end up back at our voltage. So now what does that mean as far as our capacitor goes? Well, we are given capacitance. They say C equals 2 microfarads, or 2 times 10 to the minus 6. And we are looking for Q. How much charge is on the capacitor? Well, now how are these two things related? We know that the equation is going to be given on our equation sheet, and that is C equals Q over V. So we're given C, we're looking for Q. That means now we need to determine what V is, voltage. Well, as I was saying, when we're taking our walk around the circuit, when we cross over RA, we have a potential drop of 8 volts. We're going to drop 4 more across these things that are in parallel. So that means across this capacitor, we have 4 volts. Splendid. Now we can find Q. Q equals C times V, which equals 2 times 10 to the minus 6 farads times 4 volts, which gives us 8 times 10 to the minus 6 coulombs, also known as 8 microcoulombs. They give you 2 points for that section. 1 point is for finding the correct voltage drop, and the last point is for the correct value, 8 times 10 to the minus 6 coulombs. If you have any questions, feel free to ask. You can come by my room or email me. Good luck.